Welcome to today's fireside chat on the state of data science and machine learning. Today, we're going to be sharing some recent research findings from a study we conducted in collaboration with NIME. I'm Mike Leone, Principal Analyst at Enterprise Strategy Group. I lead coverage of analytics and AI, and I'm pleased to introduce my guest today, Michael Berthold, CEO of NIME. Michael?
Hi, Mike. Thanks for having me. I'm very much looking forward to what you have to share. Let's see where the data takes us.
Awesome. Well, thanks for joining. Let's get started. So, look, in recent years, the business landscape has really witnessed a continued transformation, and it's being driven both by the rapid advancement of technology, but more so the increasing importance of data-driven decision making. We're seeing this across all domains. We're seeing it across all industries. These organizations continue to recognize the power and criticality of data science, and as a result, year-over-year spend is on the rise. The research that we conducted showed 92% of organizations are seeing a year-over-year increase in budget allocation for data science and machine learning projects and initiatives. Now, of course, the next natural question is, well, how large are these budgets? Well, a majority of the enterprises, I believe it was 54%, are going to invest at least $500,000 in people, process, and/or technology in association with data science and machine learning over the next 12 months or so. Now, that financial commitment, I think it really underscores the value add organizations are seeing from investments in data science and machine learning. And of course, look, the rise of generative AI is helping push this along at a faster clip than really anyone expected. So, Michael, first question for you. What are some of the key business objectives and desired outcomes that are driving growth and investments from your customers?
It's a good question because I do come from the data science area I come from a university where we did research on coming up with new methods to find interesting insights in large heterogeneous data sets. But the reality is still that a lot of those investments go into data infrastructure, actually making sure that people have the data accessible in one way or the other and can actually work with it. So a lot of the investments that we see and a lot of how NIME software, even though we are a data science platform, it's often used for not very sciencey type of activities. Data aggregation, getting it into shape, making sure that you have a reliable, unified, comparable kind of apples to apples kind of view on all of the data that you have been collecting over the years, day after day. And then the science piece, really doing machine learning type stuff, applying bleeding edge technologies tends to be the smaller piece of that.
Yeah, now, as organizations navigate this ever-changing data landscape, they're encountering several challenges. There's data challenges, there's integration challenges. Of course, security and governance is a big concern. But our research showed that the most cited challenge faced by organizations today when developing and implementing data science is a lack of skilled talent, right? This talent gap, it's become a significant bottleneck. There's limited data expertise. There's so slow project implementation and execution. Of course, there's overburdened stakeholders that are being asked to complete tasks outside of the normal day-to-day activities. And altogether, it's introducing a fair amount of risk, right? There's delays. In some cases, there's flat out failures. So my next question, how's the lack of data science talent impacting the ability for so many organizations to deliver on their key objectives and desired business outcomes?
Yeah, that's also a good question. I think a little bit has to do is similar to software engineering projects at the beginning, where people always thought, well, if I just double the size of the team, things will come out twice as fast. And I don't think that's quite how it works on the data science side, right? If you don't have the data under control, if you don't have unified views on the data, you can hire as many data scientists as you want, and that's not going to get you any more insights. So I think that's one piece of the equation, that there's a little bit of this hope that if I just have enough data scientists, miracles will happen. And I don't think that happens. On the other side, however, it is, of course, super critical to have people that know how to make sense of data. And that, to me, is both, it's an educational piece. So you need to know what some of these methods do. If you don't know what a regression analysis does, then you will interpret it in all sorts of crazy ways, but not the right one. And then at the other part, you also need experience. To me, becoming a successful data scientist is both understanding the technologies that you're applying to your data. And that, to be very clear, that doesn't mean I need to understand the program logic behind it, but I need to understand what a certain type of analysis does and what it means. And then I need to have this gut feeling almost that comes from experience when I run an analysis and I look at data and I find interesting insights to be able to say, that looks weird. I wonder what. And then you dig a little bit deeper, and then you realize the data isn't quite right, and something else happened, or some future data was bleeding into your analysis for past situations, and that kind of convoluted something of what we were trying to do. So I think it's not just about having many more data science curriculums at universities, and then suddenly they will just enter your company and wonderful things happen. But you need to get people that have the right education, but also a bit of an experience with that one. And then, of course, they need to have a business understanding. So just putting someone from the business next to a data scientist and those two people can't talk to each other, that's not really going to help either. So I think, to me, a lot of universities are doing the right thing by having these data science curriculums kind of crossing departments, right? Because it's not a silo application. You're not going to be the one that's just architecting something, but you really need to be able to understand business topics across the organization.
Love that. Now, another area of concern is really around the holistic data science lifecycle and really the different phases of that lifecycle. So while organizations can pinpoint specific areas, our research shows that the very beginning and the end of the data science lifecycle are the most challenging. In fact, of all areas, data accessibility, data preparation, and then monitoring and maintaining models in production are the top three most challenging areas experienced today. How much time would you estimate is spent on, let's call it, the data engineering tasks versus actual modeling and analysis work? What could be improved there?
I think there's this famous quote, right, where they say 80% of a data miner's job is spent on wrangling data and not actually analyzing it. And I personally think, actually, and from what we see, that's a lie. It's probably even more. It's probably more like a 90% versus 10% really doing the interesting pieces. So I think that still goes back to and that's what we see at lots of our customers, lots of our users. You need to have some way of setting up a reliable mechanism to access day by day the data that you have, right? And in the past, decades ago, it was the warehouse is going to solve all of these problems, right? Once we have the warehouse in place, everything is fine, which is true in theory, but nobody ever has that warehouse in place, right? By the time you have designed it and filled it with all of the data, many more data sources popped up. So you're done. You can redesign your warehouse again. So that's kind of a moving target. So what we see a lot more happening is that people use also our software in that context, where they just set up what I call a virtual data warehouse, where they keep every night or once a week, keep integrating all of the new data that's flowing in and all of the other data sources, and use that to create a unified view on the data. Once you have that, then I think the data wrangling piece becomes more of a moderate part of the work of a data science team. So the data engineering part is still something where a lot of manual time gets wasted. And it's interesting that you also mentioned monitoring and retraining, because actually in a lot of organizations that we see, they spend zero time on that. It's not even yet really on their radar. They think about it, they realize they have to do that at some point in time, but it's not yet something they're really focusing on.
Yeah, it's interesting. All these challenges, they're really driving the need for some kind of end-to-end platform that can better serve, obviously, the technical stakeholders, but we're seeing an increasing focus on empowering the business to do more with data. When we asked respondents about factors that are influencing their purchases related to data science, the areas that rose to the top included things like, integration with existing systems, ease of implementation and deployment, and of course, open source compatibility. So I want to touch on those three items just for a second. As expected, the last thing an organization wants to do is reinvent their entire data architecture and environment to benefit from data science. So they want something that can be easily integrated. And then obviously there's something to be said for simplicity and getting started. Hey, we don't want to take extended periods of time to see value from some of these investments. And then finally, the value of open source. I know we probably both see this the same, whether it's enabling collaboration, providing flexibility and transparency, gaining access to an active community, or maybe it's just as simple as, hey, for cost savings purposes, we need to go down this path of open source. 88% of organizations agree open source is critical to innovation in data science and machine learning. So knowing the prevalence of open source software used to support data analytics, data science, machine learning, how important is simplicity and integration with an existing tech stack?
That's really almost three topics at the same time. So I think the simplicity really relates back to the ability to in the same environment do the data transformation, the data blending, the data accessing, the modeling, but also ideally also the deployment and the monitoring and the retraining, and make sure you don't have to stitch together 5, 6, 7 different technologies that are never really quite compatible, but it's part of the same environment. So I think that's just speaks to something that at a level of abstraction allows people to collaborate, even though underneath the hood, they're using very, very different technologies, right? SQL for the data integration piece, Python, R, some strange, beautiful C libraries doing some of the analytics, JavaScript, some other visualization framework for the visualization, just to name 3, but there are many more out of that. So making sure that the data science team, and science here really, just like we discussed at the beginning, incorporates all of data engineering, all of those transformation pieces as well, that they can work together at an abstraction level that they all understand, right? They don't need to understand all of what they're doing precisely. What is he doing with this outer join here? And what is the machine learning expert doing on with this neural network weird stuff? But they know that something happening. They can see that, they can communicate about it in the same environment. So I think that piece is super critical, that you have a unified platform around that. It's almost like you have an operating system for your data that everybody can operate, and that ties together all of these different technologies. The open source piece, in order to stay ahead of innovation, I think is super important, because in my mind, there's no proprietary software company out there that can play catch up with what's going on in the field. There's so much new cool stuff popping up every day somewhere in some research lab. Half of that stuff, probably much more actually than half of that stuff, will disappear again, right? But you want to be able to experiment with that, try that out. Does that actually add value to what we are trying to do inside my organization? So you need to have mechanisms that allow you to reach out to these new developments. And ideally, it's even an environment that encourages those research groups to integrate their developments back into the platform, so it can very easily be used.
Great.
And the value of open source, in my mind, is just like, this is some other areas are kind of mature enough that you kind of know what you need and what's probably going to happen in the next 2 years. If you ask me what kind of data sources we're going to analyze in 2, 3 years down the road, what kind of techniques we're going to use, I don't know. I have a hunch here and there, but I really don't know for sure.
It's changing so rapidly. Who knows? You can't predict what's going to happen in the next couple of months, never mind 2 years down the road. So I want to shift a little to MLOps now. Look, we know organizations struggle getting models into production. This has been well cited for years at this point. I mean, it's driven a very active category of specialized vendors that are just focused primarily on operationalizing machine learning. I know there's been several acquisitions that have been made throughout the market, and rightfully so. It's likely one of the greatest challenges that organizations experience. It's a costly challenge too, knowing so much time, energy, and dollars have been dedicated to establishing a machine learning initiative, hiring the right folks, right? You're partnering with the right technology vendors, and yet organizations still struggle getting models into production. Well, our research shows that a majority of organizations have significant room to improve on their processes for moving models into production. Many models simply don't make it, right? And that's fine, because some don't have to go into production. But nearly half of organizations see less than 25% of their models get deployed into production. So, Michael, what kind of challenges have you seen from customers when managing the deployment and monitoring of their ML models, and how have you enabled them to address those challenges?
It's a very good question. And to be honest, we don't see that many of our customers actually do real model management or retraining, monitoring, these types of things. And I think the first part of that is that we did spend quite a bit of time talking about data transformation being part of the data science process. Yet, when we talk about model management, a lot of people assume it's just about the model. But in many, many cases, it's also about the types of transformations that you realize during model optimization need to be done to that data to actually build a good model. So model ops really should more be, and I think Gartner calls it X ops because they couldn't come up with a real name either, but it's data science operations, right? It's a process where it's a little bit, there's some data transformation, and yes, there's a model or complex model or an ensemble model that's part of that, and that stuff needs to be moved in production. So what we see in a lot of the organizations that are working with us is that they have a more or less manual process to do that, right? Once they've wrapped it up and packaged this production process, right, they have a way of giving it to ID or to IT or wrapping it into a REST service, and then people can start using it in production. So that piece kind of works. getting that into a stage where you can do that almost at the press of a button in an auditable way, so that also you can go back and say, hey, what was the model that produced these strange results a year ago, is already a lot more complicated. And the moment you start talking about the requirement to also do that in a continuous fashion, so that you can continuously update this model and do it with more than 3-4 models, but with 100 models or 1,000 models, that's when a lot of organizations have a bit of an aha moment and they say, oh yeah, that's a good point. We should start thinking about that as well. Right. And the way we are addressing that is that we have mechanisms that allow not only to customize the data science creation process, but there's also mechanisms on the NIME Hub that allow you to customize how you want to deploy that. Right. Some organizations, it's maybe less critical. You just want to make sure your development environment and the production environment are separated. Fine. Other organizations maybe have more requirements. They want to make sure there's some validation step in the middle that actually makes sure the model not only passes tests, but actually produces similar results on past data. You have golden data, some standard data where you say anything we put in production should at least not mess this up, right? Then you may want to even put something in production where you say, let's run this as part of an A/B test for a couple of weeks to make sure the new model is actually not worse than the old model, but really better before we really replace it for good. And then, of course, there's this entire topic of, well, once the model is in production, it's not in software engineering. When you put a software out there in production, you want to make sure it keeps running, right? In data science, when you put a model in production, you want to make sure it keeps running, of course, but you also want to make sure that it still produces meaningful results. And that's not because the model gets worse, but reality changes, right? So you have these issues of model drift and model change, and that's something you need to automatically detect and then alert your data science team to say, hey, something's out of whack here, please rebuild this. Or ideally, you actually have an automated mechanism that retrains the model on newer data, puts it back in production, and you kind of close that cycle. That's something we see at a very, very small fraction of our customers to really have that up and running. Some are doing amazing things at that front, by the way, but not many.
Yeah, it's interesting. I think there's a level of maturity that needs to be considered too, and a level of scale where maybe organizations aren't at the scale yet where they can exclusively and definitively benefit from some of this technology. So now I want to shift on, to NIME, right? So Michael, you founded NIME, what, over 15 years ago at this point? Been a great ride so far. Still so much to come. Can you share with listeners how NIME is enabling its customers to confidently pursue data science at scale?
So there are two things to that. So one thing, from day one, we have made sure that NIME workflows are 100% backwards compatible. So what you built many, many years ago in NIME version 1 will still run, and it will not only run, but it will produce the same results. And that's not many other platforms can make that claim. So I think that's super important in order to be able to reproduce results that you're in the past that will become increasingly more important when we go more into governance and auditable kind of things. So I think that reliability to be able to say the environment that we're investing, that we're implementing our data science IP in will continue to work the way we expect it to work. And then the other piece is, as we talked about all of these different technologies, the way you're building data science processes in NIME in this low code environment allows us to, underneath the hood, swap out technology when something new shows up without everybody needing to learn how to interface that new technology with the other pieces that we have. So one good example is when deep learning first showed up, we were integrating the deep learning for Java library, which is a Java library, was kind of the thing to use back in those days, but that very quickly got replaced by Keras and Python libraries. So we kind of swapped that out, but the way you're building deep neural networks and how you're training them still looks very much the same in a NIME workflow. So this ability to make sure we modernize technologies that keep coming and keep disappearing, but the environment that people are using, the data science team is using, from the data ingestion, transformation, all the way to the visualization, stays the same. I think that's super important. So that allows people to really build sustainable data science practices. And then the other piece to that, I mean, that's the open source analytics platform that allows you to build these data science processes. And then on the other side, we have the NIME Hub that allows people at various skill levels to work in the same environment, right? If you're interested in automating something you're doing in your spreadsheets, every quarter you have to run the same kind of data aggregation reporting mechanism, you build a NIME workflow doing that. You're using 50 nodes for data aggregation and data transformation, right? Then you learn more about, hey, I can now, first of all, I'm saving time because I now do that at the click of the button. And secondly, now that I have all of this data and I have it repeatably and reliably in the same format, I could start running forecasts, right? So you start learning, you kind of educate yourself around, hey, what is linear forecasting? How does time series forecasting work? And then you start using other modules in KNIME that allow you to do this kind of analytical work, right? And then at some point in time, you start becoming curious about AI technologies. And you say, okay, I don't need to learn yet another framework. I can, within that same KNIME work low-code environment, I can also reach out to AI technologies. So one way for us to really broaden the use of KNIME inside organizations to make sure we address all of those different skill levels. Or I actually prefer not to think about it as a skill level, because it's not like the spreadsheet automation master it's a different skill set, right? Not a lesser skill set than building AI models, but they can kind of wander between those different worlds and stay in the same environment. And I think that really helps us to have thousands of people in organizations using the same environment for rather different things.
Yeah, it's about empowerment. It's about enabling the wider business to consume and utilize data science on their terms, right? That's been an initiative for KNIME for years. And look, this level of enablement is increasingly important across the broader market. I feel like everyone is now talking about self-service and business user empowerment. It's driving a greater need for simplicity, for automation, communication, collaboration. One of the findings from this research shows that 90% of organizations agree that collaboration and interdisciplinary approaches to data science will become increasingly important. And then 87% believe building data science skills across domains and business users will be critical going forward. How is KNIME enabling this level of collaboration and helping bridge the gap between business users and data science teams, the so-called generalists versus experts?
Yeah, that's true. So I think it's almost like a vertical and horizontal axis. In one point, it's about making sure that you use the same low-code environment to do different types of things, right? From the data engineering all the way to the analytics and the visualization part. And that allows people that have very different skills. I mean, the data engineer knows a lot about data structures that are floating around, where they're coming from, and how to best put them together to make sure that we have the view of the data that we need for the analysis. And the AI expert has a different skill set, but they can collaborate in the same environment. So that allows us to pull all of these skill sets together. And then being able to have the business user understand what the data science team is actually putting together to solve his or her problem, I think is also super important. And rather than having to show them a long code and walking them through lines of code, and this is what happens here, and this library with the strange name is doing that and this, they can show them a visual representation of a data flow, where they can just walk them through the steps. Like, this is where we're reading the data, this is where we're kind of merging together, this is where we're removing all sorts of outliers in the data, that and that. Kind of, you have the visual documentation at the same time. And that also allows us to do another thing where we have these KNIME workflows support users that probably wouldn't be able to create a KNIME workflow from scratch to solve that problem. But we can serve them with a blueprint that solves a very similar problem. Here's something else that is a churn prediction workflow, right? Use this as a starting point. And then it's a little bit like a lot of programmers do that as well, right? They kind of copy templates and modify them to their needs. And you kind of take a workflow that's solving a very similar problem. Maybe it's reading the data in a slightly different format, so you need to change something here. You want a slightly different representation of the output, you change something here, and that's it. Voila, you have the solution to your problem. And I think that's really a way to empower also business users to get their hands increasingly dirty, in a sense, and start doing some of these things themselves. And then, of course, and that we see that in many of our, especially larger organizations, they're super happy that they can educate everybody who wants to about how can you make sense of data. They can start using the open source analytics platform to play with the data. There's a lot of online resources to learn how to do everything from data blending to sophisticated analyses. And they can educate themselves or in a team and learn more and start kind of going up this skill ladder on the data science side.
So I'm excited. This sounds great. I want to make it real for listeners. So could you highlight a customer example or maybe a case study of how KNIME has empowered an organization to really broaden the adoption and use of data science?
So there's a customer who has presented at some of our summits before, Continental. It's a automobile manufacturing industry, and they're essentially not doing a lot of sciencey stuff. They're also doing sciencey stuff, but the biggest push there was that they essentially enabled a lot of their spreadsheet people automating repetitive tasks, saving lots of time there. And also, to be honest, make it a lot more reliable, right? If you keep pasting, copying and pasting into spreadsheets, you'll eventually lose a column and a row or something. And it gets worse and worse. It deteriorates over time, right? But if you have a 9 workflow that keeps running, it will consistently produce the same results. The nice thing there is Continental is also a company that contributed, going back to the open source story, right? They were lacking a bit of functionality for spreadsheet formatting type of things. So they contributed a couple of nodes back into the NIME open source ecosystem as a community contribution, which is also a nice little example.
I love that. Well, this has been great. Thank you so much for joining today, sharing your perspectives and insights. As always, thanks to the listeners for attending today's webcast. If you haven't already read the report that we've been discussing some of the results from, we'll drop the link in the chat. Additionally, look, if you're interested in NIME and their enterprise capabilities, you can click the Contact Us button at, I think, the left side of the screen to get in touch with the NIME team. And I'll just say stay tuned for more from NIME throughout the rest of this year and beyond in this space. Have a great rest of your day.
Thank you.